All right, Rachel, do you want to take it away?
Sure. Welcome everyone to our next keynote talk. We're very fortunate to have Rakesh Vohra here as our speaker. He is the George A. Weiss and Lydia Bravo Weiss University professor at Penn. He has done tremendous work across many fields, including economics, operations research, computer science, and as such, he is known across multiple fields for his work there. Here in the FORC community, we are very fortunate to have him working in this area too. And today he'll be talking about algorithmic interventions versus incentives. And before we go into his talk, I want to give everyone a quick note about how to handle questions. So if you have questions during the talk, then type them into the Q&A box, and you should see it to the bottom of your screen. There's a Q&A box. If you hit that, then you can kind of open that and type a question. At the end, we'll have time to handle those. All right. Thank you, Ricky.
Well, thank you very much for that kind introduction, Rachel. And thank you also to the organizers for this privilege. Regarding questions, just so this doesn't sound like one hand clapping, Rachel, feel free to interrupt at any time when the questions come through.
Sure.
So when I was asked to give the talk, it was suggested that I try for something a little broader and perhaps emphasize the economic perspective. So that's what I've tried to do here. So the question I'm going to pose is the following, which is, well, actually, so let me start it a little differently. I'm going to assume that I'm preaching to the choir here, which is we understand why there's this concern with algorithmic fairness. And on the slide, you see 3 bullet points about research questions that arise given this concern. I'm interested in the last one. So if the outcome of an algorithm is bad, you choose the definition of bad. What's the intervention that you have in mind? Now, the intervention that I have in mind, which has attracted a lot of attention, I'm going to call an algorithmic intervention. In other words, you go in and you impose an additional constraint that your prediction algorithm should satisfy. So that could be equalizing of false positives, equalizing positive predictive value, perhaps suppressing the use of certain independent variables. If you want an example of the kind of thing I have in mind, Adrian's talk from this morning, I think would be an archetypal example of what I would consider to be an algorithmic intervention. Okay. So what I want to do is I want to contrast algorithmic interventions with the role of incentives. Before I do that, there is one remark I want to make, which is in Adrian's discussion about imposing additional fairness constraints, he was very often evaluating the effect of these constraints on accuracy. And I think it's worth arguing, or at least pointing out, that
Ricky, I just want to check, we might not be seeing your slides correctly. We're still just seeing the intro slide.
The one titled Algorithmic Fairness, that's correct.
That's right, oh, okay, yeah. Thank you.
Which is that accuracy itself, I think, is as contestable a notion as equity, because at least the usual definitions of accuracy assume that weight all mistakes equally. Right?
Sorry,
so,
we're not seeing a slide that has a title Algorithmic Fairness. We're seeing just the title slide. I think
okay.
You might have to make it full screen and share.
So, okay, hold on. Let me stop sharing for the moment. Shut down various things. Okay, you still can't see the slides, correct?
That's right.
Right.
Jason suggests first full screen, then share screen.
Yeah, that's what I'm trying to do. Okay. How does that work?
It's
We're seeing a
currently
black
screen.
black screen.
Ah,
We could see the slides before you went to full screen, so maybe we can just
okay,
go
you can
through
see
this way.
these, right?
Yes.
Yeah.
Okay. Yeah, it's not allowing me to do full. Yeah, okay. Sorry, let me catch my thread. Yes, before going on, I just wanted to point out that accuracy, I think, is as contestable a notion as equity. There's no reason to privilege it over equity because accuracy is commonly defined, weights all mistakes equally. Okay. Now, so I said I wanted to contrast algorithmic interventions with the role of incentives. So to frame the discussion, I want to begin with an assertion that I hope is uncontroversial, which is we only care about predictions insofar as they help us make decisions. So on this slide at the top line, I have written down in stylized form a generic decision problem. So little a represents a possible action you could take. Y represents the outcomes that you might be interested in. P of Y is the probability that you will see outcome Y. And U of AY is your utility or payoff function. And notice that depends on both the action that you take and the outcome. So ideally, you would like to match the action to the outcome in some sense, but you recognize that there's some uncertainty over the outcomes. Now, there are two algorithmic problems here. One is choosing the optimal action A, that's an optimization problem. And the second is estimating P of Y, the probability of seeing outcome Y. Okay, now, if you look at the outcome of that decision problem, and to your mind it violates some notion of equity, we might ask, what's the reason for that? And there are at least two possible sources. One has to do with preferences or the utility function itself. So just to remind you, the utility function appears there in the second line. And one reason why the outcome of this decision problem might be inequitable is perhaps because of the way you've chosen to write down your utility function. So what could be wrong with that? Well, one, your utility function could be incompletely specified, meaning I gave you an objective, you optimize with respect to the objective, I look at the solution and I realize, oh, wait a minute, the solution violates some other property that I thought was important that I neglected to encode in the utility function that I gave to you. Now, if this is the case, notice the optimization problem can only discover whether this has happened. It cannot tell me how to correct it. That has to come from the decision maker. So there's no algorithmic intervention in item number one. Second possibility, my preferences as reflected by you could in fact exhibit a taste for discrimination. Okay, so those are my tastes. You may find them objectionable. And that would be the explanation for why the outcomes would violate a notion of equity that you have in mind. However, if my tastes are a minority taste within a larger market, then we have Gary Becker's argument that says in a perfectly competitive market, I will be driven out. And so in some sense, a market will correct for this inequity. So again, no role for algorithms here. Okay. Third possibility is that my utility function does in fact reflect a taste for discrimination. It's a minority taste, and the market doesn't correct for it because it's not perfectly competitive. So here you might think there's perhaps a role for an algorithmic intervention. And to me, that's not obvious because presumably the person who has to intervene is myself. And why would I want to intervene in a way that would contradict, that would go against my preferences? So in item number 3, it's not obvious that an algorithmic intervention is relevant here. Now we get to item number 4, which is, what if my utility function that I've asked you to optimize for reflects a widespread taste for discrimination? Well, therefore the Becker argument won't apply. But in this case, I would argue the challenge here is political, not a technical one. Again, I cannot see that an algorithmic intervention is going to succeed here. Okay, so that's on the preference side. The other possibility is that there's something wrong with the way I'm constructing my predictions. So again, stylized form. Imagine I have in mind a model that relates the output or the outcomes I'm interested in a linear way to 2 things. One is GI, a dummy variable that indicates your membership in a particular minority group or not. XI, which is a vector of all the attributes or characteristics that I think affect the relevant dependent variable. And epsilon I is just the standard noise term. Right? You could imagine a more complicated model than the linear one, but it's not essential for my purposes. Right? So if you want to attach labels to these, you could think of YI as being wages, and you could think of XI as being all of the characteristics that I think affect your productivity. Now, if XI captures all salient attributes and group membership is uncorrelated with the noise term, if I ran this model and I discovered on your data, and I discovered that the coefficient on the group membership variable A was negative, this would be evidence that I'm discriminating against that particular group. Right? Okay, so economists would call this statistical discrimination. And again, we could ask, why might this be happening? And again, let's go through the reasons to see whether there is a role for an algorithmic intervention. So first reason could be that maybe the model I trained on was not using the actual outcome, but a proxy for the outcome, and it was a rather poor proxy. In that case, I would argue the intervention is not algorithmic, it's get the right proxies or try to measure the outcome. The other possibility is that I was training my prediction model on unrepresentative training samples. Okay. Now, there are, I think, at least 2 papers at this conference that are discussing this problem. One, I think, suggesting an algorithmic intervention, and I think the other arguing that perhaps no intervention is needed. So let me talk about the second one, which is the fact that the original training data is unrepresentative does not immediately imply that over time, your prediction algorithm will eventually stop repeating those errors. You could imagine your algorithm learning over time and correcting the earlier mistakes. Right? Now, that requires a formal model, but I'm just offering an informal intuition about why we might be skeptical about the need for an algorithmic intervention. And if you thought your initial data set were unrepresentative, then wouldn't the correct intervention be to get a representative data set rather than tinkering with the prediction algorithm itself? The second reason why your prediction model might discriminate against a particular group could be that the outcome variable that you're interested in depends upon group membership. And it's not hard to come up with examples. I have one there on the slide. Another perhaps more well-known example is in the competition for advertising slots. There's a paper by Catherine Tucker, and I forget the name of her co-author, which illustrates that certain employment ads are not shown with the same frequency to women as they are to men, not because of any intention on the part of the platform to discriminate, but simply because there are other advertisers who wish to advertise something other than jobs and are willing to pay a higher price to get their ads in front of women's eyeballs. So in this case, again, it's not obvious what an algorithmic intervention would be and why it would be needed. If somebody is willing to pay more to get the attention of a female eyeball than someone else, it's not obviously a bad thing. Right? Third possibility is that the coefficient on the productivity variable B is not exogenous. So here's the story that I have in mind. Historically, it has been argued that women should not be fighting fires because that requires a great deal of strength. Right? If you think about that argument, that depends upon the current technology for fighting fires. You could imagine a change in the technology, which would then require that those who fight fires don't need as much strength as they used to do. So in that sense, the coefficient B could be exogenous, it could be endogenous rather than exogenous. And so therefore, it's this underlying choice of technology which results in the discrimination. Fourth possibility is that the productivity variable, xi, the variable that you believe tells you something about the outcome variable that you are interested in, maybe that's not exogenous as well. There could be at least two things going on here. One, it could depend on discrimination at some other stage of life. So if you think about xi as productivity, perhaps the reason a segment of society is lower productivity than another segment is not because they inherently have lower productivity, but because they've had fewer opportunities to invest in increasing their productivity. A second reason could be that at a cost, an agent may be able to modify the xi. And so this has come up before in some of the earlier talks about strategic classification. So again, if I look at item number 4 and I look at item number 3, it's not obvious that an algorithmic intervention could help. So that leaves me with item 5 and brings me to the technical core of my talk. What if the dependent variable, your outcome variable itself, is endogenous? So what I'm going to describe now is a model, and you'll see who my co-authors are in a moment. And the point of this excursion into a model is that within the model, I can make the following arguments. If we focus on the incentives of the decision maker, as well as the incentives of the agents who are affected by the choices of the decision maker, then these debates about what is the right fairness criterion, whether you should suppress a particular variable or not, all of these evaporate. So in that sense, it seems like incentives may have a greater role to play than algorithmic interventions. And that's sort of the argument that I'm making today. And notice my qualification, it's the argument I'm making today because I want to leave open the door to the fact that I might change my mind tomorrow. Okay, if there are no questions at this point, and I'll pause for a second here, just in case there are any.
And also as a reminder, if you have any questions, type them into the Q&A box, and then we can answer them as we go or at the end.
So Eloni Cohen asked me, can I clarify the meaning of endogenous or exogenous? So think of exogenous as meaning it's fixed ahead of time, if you like, by a supreme being and cannot be changed. Endogenous means it can be changed perhaps by the agent whose behavior you're trying to predict, and therefore could be affected by your predictions. Does that answer your question, Eloni?
He says yes.
Okay.
Thank you.
Okay, so I'm interested in an environment where the outcome that I'm interested in predicting is endogenous. This is based on joint work with Christopher Jung, Sampath Kannan, Changhua Li, Malesh Pai, and Aaron Roth. Here's the baseline model. You have individuals from different groups who rationally compare payoffs from legal opportunities with the payoff of committing a crime. So the reward from committing a crime is R, and if you are penalized, and there's a chance that you'll be penalized if you commit a crime, and the penalty is an amount capital C. Okay. Now, groups are not identical in this model. They differ in their access to legal opportunities. So the way you want to think about it is, I can commit a crime and receive a payoff of R if I avoid punishment, or I can choose not to commit a crime and then I will receive some payoff from my outside legal opportunities. Okay. The access to legal opportunities can differ by group. And we think this is an important part of the model because we want to capture the idea that groups aren't necessarily identical ex ante. If you commit a crime or you choose not to commit a crime, either action, that will lead to a noisy signal. Think of the noisy signal as evidence about whether or not you've committed a crime. Okay? Now there's an adjudicator who will observe both your membership in a group and this noisy signal. And on the basis of these two pieces of information, will decide whether to impose a penalty. Okay. Now an individual from group G, little g, has an outside option, value V subscript I. Only she knows what that outside option value is, and it's drawn according to some distribution D subscript G. So notice the distribution over the outside option values depends on which group you belong to. The adjudicator knows the distribution, but may not know the particular outside option value that an agent has. Agent has two actions, little c, commit the crime, little n, choose not to commit the crime. Once you choose an action, that generates a noisy signal that is drawn from some distribution that depends upon the action that you choose. And what you should have in mind is that higher signals are more likely to come from S superscript C, meaning if you think of the signal as a number, the higher the number I see, the more likely it is that you've committed a crime.
Ricky, there's a question. Ushnish Sengupta asked about the difference between short-term incentives versus long-term impacts. And they say unfair algorithm developers can be financially rewarded in the short term, but these negative impacts may be long-term on a different group. Any thoughts on that, or do you want to wait until the end?
So given my understanding of the question, it is not clear to me why the temporal aspect is important, because as I understand it, when I design my prediction algorithm, I am in effect choosing which groups will suffer errors. And so that choice remains whether it's static or dynamic.
Okay, thanks.
Does that?
Maybe we can hold further conversations about this point until the end if it isn't like an immediate clarifying question.
Okay.
Yeah.
Okay, so returning to the model, an agent has a choice, which is they can choose action little c, commit a crime. They can choose not to. Whether they choose one of those two actions, they will do that to maximize their expected payoff. Once they choose an action, that generates a noisy signal. There's an adjudicator who looks both at the noisy signal as well as the group that an individual belongs to, and then makes a decision about whether to punish them or not. Okay. What's important here is that the distribution of the signals depends on the action, not on group membership. And an adjudicator observes each agent's group membership and signal. And what the adjudicator basically has to decide is a penalty policy, which is, given your group membership and the signal that I observe, what is the probability with which I will punish you? Okay. Now I have to tell you what the adjudicator cares about. Okay. Actually, no, I have to give you some notation first. Okay. So fix the adjudicator's policy. TP subscript G, that is the true positive for group G. So given you committed a crime, it's the expectation over the event that I punish you. And then there's the false positive for the group G, FPG, that's the expectation over the probability that I punish you, given that you didn't commit the crime. And an individual from group G will choose the action to commit a crime exactly when her expected payoff from choosing the crime exceeds her expected payoff from choosing the outside option. And that's the penultimate line on that slide. And let me pause here so that you can take it in. Now, as the adjudicator, once I've chosen little f, my policy, because the groups have different distributions over their outside options, the proportion on each group, the proportion in each group that will choose to commit a crime is going to vary. So the base rate, P subscript G, the fraction of individuals within each group who choose to commit a crime, will be different. So here is the adjudicator's objective. She wants to choose a little f, a penalty policy that will minimize the overall crime rate. So what have I done so far? There are basically two agents here. There is the adjudicator. I've told you exactly what the objective function she has. And there is an agent, and I've told you exactly what her objective function is. Now, how should the adjudicator choose this policy? In other words, I see a signal, I see the group you belong to. How should I decide whether to punish you or not? Right? Well, the most natural thing that you might think of is, well, I see the signal, I see the group that you belong to, I can update any prior belief I had over you committing a crime, and that produces a posterior. And if that posterior exceeds some threshold, then I should punish you. And then a question you might ask is that threshold going to be group independent? Because if it is, that satisfies at least one notion of fairness that has attracted attention in the literature. So equality of positive predictive value, I think. Well, the difficulty with this approach is, in order for you to do that Bayesian update, in other words, to work out the probability that you committed a crime given what I've observed, I need to know the base rate. And the problem is the base rate is defined in equilibrium. So it's not immediately obvious how you do this. Now, the other thing to keep in mind is because the base rates in the two groups will differ, group membership is statistically informative. And the other possibilities that you could think about are setting thresholds to equalize some other outcome statistic of interest, like false positives or false negatives rates, and so on. Now, as you know from the work of Cholducheva, Kleinberg, and Mullainathan, a number of these measures of equity, equality of positive predictive value, equality of false positives, these are frequently incompatible with each other. And there is some debate about which of these that you should be using. Okay? The point we want to make in this model is that this debate is simply absent. By focusing on the incentives of the adjudicator and the incentives of the agent, we will learn exactly what we should be doing. And so that sort of settles the question of what is the right fairness measure. Okay, so let's take a look at how an agent decides. An agent I in group little g will choose to commit a crime if her expected payoff from choosing the crime exceeds her expected payoff from not. So if you look at the second line of the slide, the left-hand side denotes the expected payoff from choosing not to engage in the crime. It consists of two components: the value that she earns from her legal outside option, less the expected cost of incorrectly being punished. Notice the FPG on the left-hand side. The right-hand side of the second line of that inequality shows the expected payoff shows the payoff from the crime less the expected cost incurred if you're punished. And now what would the crime rate in group G be? It would be what you see on the fourth line of that slide, which is the probability that your outside option has a value less than R, which is your reward from the crime, plus C, that's the penalty that's assessed by the adjudicator, minus the difference between the false positive and the true positive rate. Now, if my goal is to minimize the overall crime rate, then what do I want to do? Well, the first thing is I don't have to solve this problem jointly for all the groups. I can do this group by group. So I can, because I'm allowed to condition on group membership, solve the problem for each group separately to minimize the overall crime rate. And if I look at the expression for minimizing the overall crime rate, it's not hard to see that I should focus on this term here. I want to make that as small as possible, which is equivalent to making this as large as possible. So if you look at this term that I call delta subscript little g, it basically captures the incentives for the agent to commit the crime. Or rather the disincentives. Actually, that wasn't phrased very well. I want to make the benefit of not committing the crime as large as possible. What's interesting is that this term here does not depend on the distribution of the outside options. Given this, it follows that my policy as the adjudicator is that I'll operate the same policy for every group. Sorry. I apologize, those little scribbles carry through. So the optimal policy does not depend on group membership. It only depends upon the signal, which means that the optimal policy equalizes the false positive and negative rates across all groups. So notice, by focusing on an objective for the adjudicator, minimizing the overall crime rate, a particular equity notion emerges naturally, which is equalizing false positives across groups. Now, what we think is interesting here is that even though group membership is statistically informative, the adjudicator makes no use of it. And that's because conditioning on group membership would distort incentives. So notice in this example, the decision about whether to include a particular sensitive variable or not, that decision is resolved quite naturally from the solution of the optimization problem. In this example, it turns out you do not include group membership when making a decision about whether to punish or not. Okay? Now, if instead you advocated for using the equal threshold to the posterior probability of crime, which has been argued for example, by Goel and others, that would be a suboptimal policy in this environment. And the reason it is suboptimal is because even though in their paper they argue it's optimal, is because in their paper, the decision to commit a crime or not is exogenous. In our paper, the decision to commit a crime is endogenous. It depends upon the punishment strategy of the adjudicator. So notice the incentives of the agent who is being subject to the policies of the adjudicator play a role. And by paying attention to those incentives, again, this issue of whether you should suppress a variable or not, whether you should use equal predicted positive value or not, all of these are resolved naturally within the model. Now, you might wonder about the robustness of the results in the model, so let me quickly run through some features that I hope will convince you that this is not a delicate model. The penalty costs and rewards for the crime, I assumed were the same for all individuals. They don't have to be, and they can be drawn from group-dependent distributions. The result doesn't change. Does the result depend crucially on the fact that the agents making the decision are fully rational? The answer is no. We can allow them to pick a random action, a random suboptimal action with some probability that could potentially decline with how suboptimal it is, and the result doesn't change. Is it crucial that the adjudicator observes signals with the same frequency from agents from different groups? And the answer is, in the paper we show, no, this is not essential either. We introduce an intermediary with different incentives from the adjudicator who decides which signals to report or not to the adjudicator. Okay? However, what is crucial is the following, which is if the signal distributions differ by group and not just by action, then this result that the optimal policy is group independent is no longer true. However, even in this more general setting, it doesn't follow that you should be using equal positive predictive value or equal false positives as the criteria for choosing the optimal policy. So that brings me to the end of the talk. Happy to take questions.
And as a reminder, type your questions into the Q&A box. I will answer them there. In the meantime, we'll give everyone a chance to type up all their questions. I have one, Ricky.
Sure.
So you had mentioned on the previous slide that the optimal punishment strategy ignores group membership, and this is different from some previous work that had modeled the choice to commit a crime as being exogenous, and they found they found in that case that the optimal punishment strategy should like depend on the group.
Mm-hmm.
And then like in your last slide in this kind of like robustness check, then you mentioned that your like results still hold if you allow for like group dependent distributions of these like penalty, cost, and reward. Can you talk about kind of how those two results fit together in terms of having a group dependent penalty cost distribution, but not necessarily group dependent punishment strategy?
Okay, so the informal answer would be an agent cannot control which group they belong to. So if you try to reward or punish them based on the group that they belong to, you're rewarding or punishing them for things that are beyond their control. So the usual rule in compensation and in other settings is you want to reward or punish agents for things that are under their control. And in this case, the only thing that's under their control is whether they choose to commit a crime or not. Now, the algebra itself depends upon this delta G term here, which is their incentives to commit a crime depend upon this object, which is the difference between the true positives and the false positives. And this is what, and in a sense, what the optimal policy is trying to equalize this across groups.
Great, thanks. We also have a question. Michael Yang asks if you can speak a bit to the empirical validity of this model, and it's okay to like speculate there. Alternatively, what do criminologists think of this model?
Okay, so so really the essential feature of let me first preface this by saying I told the story in the context of somebody choosing to commit a crime or not, but it should be clear that that's just a label for the variables. One could think of other labels, which would give you other stories. But focusing on this particular framing of the model, there is a debate within criminology about whether potential criminals rationally respond to punishments or not. There is one school that says, no, that's a bit of a hard assumption to stomach, because it could be that many crimes are perhaps not entirely thought out. They're more sort of one is in the moment. Right? There is another school that has argued, no, rationality plays some role. And that's why one of the robustness checks that we do in the model is we drop the assumption that the agent picks the decision that necessarily maximizes expected payoff. Now, on the empirical side, there is evidence that says that as you change punishment policies, we do change behavior, but my understanding there's debate about how big those changes are. And the most recent version of this debate has been the large drop in crime rates in the last 15 years within the US. And the argument has this been because of more vigorous policing? That's one school of thought. The other school of thought, it's just an aging population. And I don't know that there's widespread agreement.
Robert A asks, can we clarify how the optimal prediction rule F can be like impartial to different groups, while the true and false positive rates per group may be different?
Okay, so okay, that's a good question. I'm trying to think whether I have the slides to answer that. No, I don't have the slides here to show you the algebra. So I'm going to retreat to the answer that I gave to Rachel earlier, which is, if my goal is to discourage you from committing the crime, then I should pay attention to the things that you can control rather than to the things that you cannot. Group membership is something that you cannot control, and therefore I should not condition my rewards or punishments on that. By the way, the paper is up on archive, so the details are there. Yeah.
Great. Jonathan Roth asks, what if the adjudicator cares about things other than the overall crime rate? For example, if there's a direct social cost of incarceration.
So we haven't considered that possibility, and there's no objections to doing that. Instead, our point was to say that if you think carefully about the incentives of the adjudicator and the agents, working through those incentives may resolve these debates about what is the right notion of fairness to use. So certainly what you could imagine is going back and changing the adjudicator's objective function to see whether building in an explicit concern for incarceration rates would change the outcomes. My guess is not.
Great. Salil Vadhan asks, what is the correspondence between the model and these results and the model discussed at the beginning of the talk?
Okay. So let me go to the beginning of the talk. So I put up this decision problem, and then my interest was in the P of Y term, which is the probability that you might commit the crime. And so in terms of the model, there's group membership, and these might be other things that affect YI, whether you commit the crime or not. And so here, this could be, this thing here, YI, whether you commit the crime or not, what we were changing was that this was endogenous. This would depend upon XI, your policy, your threshold for whether I punish you or not.
Great. Any last questions? Type them frantically. Otherwise, let's all thank Ricky for this fantastic talk and the very inspiring discussion that it sparked. Thanks, Ricky.
Thank you very much.
Thanks, Ricky.